right, so let me import this package. Okay, here's the lab 5. So there's different. Is there anything? No. Okay. So there's 4 maps here. Let me go to lab 04. Let me see. Nope. 2, 3. There we go. Okay, we'll start with map 3 because this is going to be our traffic light. One thing that I have with the traffic light, basically, I have these. Here's the case. Here are the lights themselves. Note that this has on here this handles text. So it's just basically writing out some data information. Game manager. Find object types. We'll worry about that's from the other lecture. So we'll worry about that. Yeah, we'll not worry about these. But effectively, basically, what you are going to have here, if we go into the materials folder, make this smaller. There we go. So basically, I've given you all of the materials you're going to need. Like, here is effectively this is no power. So there we go. They all have the no power material. But I've given you a red off, a green off, a yellow off material. Do I actually have a material? No. So for this, basically, where we would go is start. Let's go and create a new mono behavior script, and we're going to call this traffic light. We'll call it an agent. All right. If you noticed the lab document, let me close this one. Here we go. I have referenced. Yes, I have referenced Rick and Morty. It is a blatant Rick and Morty reference. We're talking about AI this week, and we're talking about, again, I got part 1 nav mesh. We're going to jump to part 2, the traffic light. And basically, this is going to create a finite state machine. I should actually be part 1. I should flip the 2 parts, but we're going to create a finite state machine for the traffic light. Use the system diagram you created in the prefab. So prefab from the previous week. Have public to hold time information for each state. Show object states. So basically, like right now, it basically, hey, red no power. Show the state of the traffic light in each. So there's a handles text. Now, what I was talking about, and this is not what I want. There we go. I have you still open. Close you for right now. I have things from earlier still open. Okay. You can close you. There we go. All right. So essentially, basically, the red light has this script handles text. So let's go to our traffic light. Let's actually apply that before we do anything else. Let's just put that right in here. Edit it. So going to be a lot of things that we'll want to grab. So there'll be public game object, red light object, and then, so these are specifically, I'm going to save this. I'll go back to Unity just quickly. It's these guys that we're talking about. So we want references to these objects right here. The next thing that we'll want to do is basically, again, public, we'll use float, red light state time. I'm gonna set these to 2. So again, we're gonna have a yellow value for yellow and for green. I have an S in there. There we go. Yeah, I'm gonna have to. There will be also public material. So we know that we want the material off. And then we'll do, oh, no. Sorry, we'll do, get it again. Red, red, yellow, and so again, we've got this for all of the material. So again, this is just setting up the objects just so it knows. And then there's also, we will want the public what did I call it? Here's lab 5, part 2, handles. There we go. Okay, so lots of variables to work with as we go out of the gate right now. I'm going to save this, and let's go back, and let's just actually literally assign everything that we need to do. So for the red handle, yellow, green handle, I actually do need to reassign the green. I can assign just these red, yellow, and green down here as well, because they have the script on them, so we have access to them. Let's go into our materials folder, and then we can green on, green off, red on, red off, yellow on, yellow off. I'll leave that right now. So let's start with let me see. In our traffic light, we are going to have 3 states, and we're going to control this by having a function that we'll call. We'll just make this public for the sake argument, but there'll be void set red. Actually, it should be enter red state. Enter yellow state. Enter green state. The next thing that I'm going to do right here is going to be effectively public void do red state. And then again, I'm going to have a yellow, and then a green. All right, so I'm going to start with, let's go back to our code. And I'm going to make a new, create a new, I'm just another C#. It's going to be our traffic light enum. We'll open that up. And this is basically not going to be a public class, but a public enum. We're going to take these out. And basically, the light enum, we're going to say it will have red, green, should do yellow. So now that we've created that, we would have our public, I'm going to put this at the top. Public traffic light enum, light state. And we will set that to red out of the gate. Yeah. Actually, we will, well, actually, one of the first things that we'll actually do is when we enter those states, we'll just basically set yellow, and then this is going to be green. Okay, so the goal here is that when we enter a state, we're going to set this enum. And what we can do, actually, I think what we can do, there we go back to Unity's quick. Yeah, there is a case handle for the case. So I'm going to go back. I'm going to actually go back when we go to our agent. There is a handle text. One of the things I'm going to do is do a do the case handle. Just to open up the handles text, basically it has a string that text, and it basically sets the handle, it sets the label up on this every single. So all we have to do is assign the text. So let's go back to our traffic light agent. So the first thing we're going to do is basically be our case handle.text red state. And we'll go in and we'll say, hey, here's the yellow state. And he'll be the green state. So I'm actually going to grab, so in start, just to demonstrate, we're going to go enter, we'll do enter green state. Just sake of argument, just to see that things are happening. And we look at this, we'll go back to the scene view. We'll press play, we'll go back to the scene view, and you will see that you did not assign. Let's go back. I didn't assign the case handle. There we go. If we go back to the scene, you can see that green state. So cool. So far, so good. Now you're going to see a lot of code like written quickly through here. So if we are I am going to do another, it's going to be a public void set material game object item material map. Okay. Basically, this is being written to make our lives easier so that we don't have to do the same work over and over again. But basically, what we want to do is we want to get the mesh renderer. Get component. And mr dot material is going to be equal to the material. So this will allow us to basically quickly set the material. This will allow us to set the material quickly. So like when we go look at the red light, we're going to do set material. Red light object material red on. Oh my god, it's not game manager, game object. So here we go. Again, I can go and apply this yellow, green, you can see right here we've got this set pretty quickly. Again, I can now grab and copy these over, and it's now just a matter of these guys to set these. Grab the handle text, so you can, and then we can now grab so now I've got all these that we can, I'll just do this lowercase. There we go. So I can go and copy these up here. This will be off. This will be on. And this will be off. I can copy that one more time. So even though I go, I'm going to go from red to yellow. Even though, so this is one of the things about states that I want to get across is that even if you go from one state to another, and that nothing's going to change on an object or a scenario, you should be setting that like when we go from green to from red to green, for example, the yellow object is not going to change, but it is the state of that. It is the property of that state that the yellow is off. So even though that nothing's going to change, you should be setting the variable for that anyway. You should be setting the object to be in that state. You should be setting it, again, our light is basically, again, in our case here, we've got 3 out lights that are on and off, each of them having their own material. And even like, again, we're going from red to green, red to green. Yellow's not changing. We're still going to say, make sure the material is off. Because if for some reason you were in another state or a different scenario, this is going to make sure that when you enter the state, everything is set correctly. Do not assume the previous, the status of things in the previous state. Is basically what it amounts to. Now we are going to have a float. And each of these, we're going to go in and we're basically going to say in red state, red, what did I call them? There we go. Red state time. This is going to be the yellow state time, and then down here, and literally what we're going to do down here is then down in here, we can write in update sorry, switch blanking out. Here's our light state. There we go. So this is going to be traffic case. There we go. So basically here I've written my switch case. So each of these I'm going to do a call do red state, do green state. I've done that wrong. Sorry. Green state, this is going to be the yellow state. And wow, this is ugly. It is. That's really, this is ugly. So this is where, I mean, we're gonna get away with this because we're dealing with a small object here. But if we were building something any more complex, this would fall apart. That means we'd have to go back, update to the enum. We'd have to go back and update this switch. And that's ugly. I mean, like literally all of these are going to go and it's going to be like time counter minus equals time dot delta time. If time counter is less than 0, red is going to enter green state. And I'm literally going to grab all this code. I'm going to copy it down here and copy it down here. Yellow is going to enter red. And green is going to enter yellow. And literally one of the things you're going to see is that each time we go through again, let's make this public. And we'll make this, let's grab this and put this up at the top right here, just to make our lives easier. I'm going to grab these values, I'm going to put these up here as well. Just to reorder them so that they'll show up in the editor better. And yeah, we're going to enter a green state. So we'll see the traffic light in action. And we can see and I can get these at 0.5. So you can see that this is changing quicker now. And I'm going 0.5 just to, this would be more like, we'll do green as 3 and red light as 1.
What if you do 0?
0 would put the, so when so you're saying the time counter is 0? That would put the state as 0, so it automatically, it would enter that state, set the counter to 0, and then the next time we come around, time counter would be less than 0. Would be a negative value, and that would then trigger the transition to the next state right away.
So would we see anything visually?
You might for one frame.
Okay.
Yeah, I mean, let's go in and I'll set the yellow to 0. You can see it went. So in this case, it's moving faster than gameplay tick is running faster than the rendering tick, so we're not actually seeing it turn to yellow. Mm-hmm. Because by the time the gameplay tick comes around, it's now pushing it to the next state. So we're running through that state as fast as possible. So
basically, this is right now the worst possible.
Oh yeah, this is a horrible traffic light. Don't get me wrong; it's not I mean, it is functioning, but the idea here is to show you, hey, states. So let's handle this differently. I'm going to rip this out. All right. Instead, what I'm going to do is I'm going to create a delegate. And so basically a delegate is let's bring up C# delegate. So basically here they've created a function, a delegate, and then they've defined what that is. It has methods as arguments to other methods. Function pointers, similar scenarios, but basically this is, so you'll see a public, and you do want them public. They'll set to be as the keyword delegate, and then what you guys know in C# is C++ as the function, as a function signature, the function prototype. So we're going to go back. So let's go to our code, and so it will be a public delegate, and we're going to call it. It's going to be a void function. State function, and it's not going to have any. So basically, it's a void function with no parameters. Why? Well, we look down here. Basically, our entry, our perform, do red state, do yellow state, do green state. void function with no parameters. So that's the function what we're looking for. Now that I've created that, I can then create a state function. I'll leave it. Actually, I'll call it current state function. And that's going to make our lives much easier. So essentially down here in enter red state, the last thing that we're going to do is basically current state function is going to be equal to do red state. And we are not calling the function, so we're just using the name of the method here. Now we are, with delegates and events, you can actually add to them. But our for purposes, basically, we just want to basically set it straightforward. So we could, in theory, add again. This is how state events are basically is where you can add multiple functions to be called. In this case, we just want to just set the state outright. So do yellow state. And then here is the do green state. And what we have to do instead is basically, in this case, is basically current state function invoke. Again, we don't have to pass it anything because it's a void function with no parameters. So if we had parameters, we would be sticking them into there. Again, we are using the question mark to make sure that if there's nothing assigned, it's not going to do anything. You've seen this a couple times, but this is the key place where we really need to do so. And now, my update function is one line of code, and two, if I needed to add another state to this object, I could. I basically would write a new enter state for it, and then a do. And that's basically, again, here is the first piece, enter state. Here is, and then here is the do, which is basically what is, for my purposes, it does not doing anything other than checking for my transition. I mean, this is what it does. It's counting down the time, and then when that goes after time, it's transitioning out. All right, and so now let's go back, and we'll go back. We'll press play, and you can see it is functioning the same. Let's put these at 0.5. And you can see that my traffic light is performing the same way it was before. But now it has that rather than using the switch statement. I mean, I'm calling one line of code, and my code is now extensible. If I wanted to add a purple state, which happens every three, let's say something like every 3 green cycles, it goes to a purple state where all the lights are on, and then it goes back to red. We can program that into the code. We need to go from, we have an impulse on the object, like we have an emergency sensor, and we need to go red right away. We can do that.
So we just need 2 functions, right?
Yeah. Basically, so in the way that I've written this right now, our states are contained in 2 functions. One that sets up the state when we enter it, and one that performs the state itself. So entering the state, And in theory, we should have an exit of the state as well. With exit states, the exit states really come in when we start. So the next thing is that what we could do is we could build this as, excuse me, build this in regards to the agent would have then 3 subclasses, which would then have the enter, the perform, and it would also have an exit. So we could call exit before we go, and that what we would do is we would switch. What we would do is we basically on the current state class we would call the exit function, call the enter function on the next class, and assign that as the current and assign that as the current class for our states.
That'd be in a separate class, right?
Yeah, that would be we would that's something I would probably again if we want to do the traffic light. What we would want, I'm just going to do 2 examples just to show you. This would be traffic. I'll do TL state base. And in here, I'm going to leave it as mono behavior for right now, but it would have public void enter state, and actually public virtual void. And it's really going to be perform state, and then would be exit state. There you go. Those would be the three methods that all of my traffic lights would need. And this is you'll probably have a similar version of that if you're going to go in this direction. So there would be a red state. One of the things that you might want to have is you might want to pass the traffic light agent the other thing you might pass would be like float. This would be time, so this would be delta. So in other engines, you would pass the delta time to the perform state. We don't have to because we got time.delta time as its own class here in Unity, so we don't have to do that specifically. But in other engines, you would. Why would we pass the agent itself? So that we have access to everything that we have. Again, all of these variables are access to it. We have access to all of these. So it would be agent.redLightObject. Set the material. Also, the set material function we would have access to because it's public. All of these functions would get pulled out of here, and they would get put into effectively the child classes. So let's just do the red. Let's go back to Unity and let's make another create monoscript behavior. This would be TL red state. So I'm going to just grab these just to make our lives easier. Here is the red state. I'm going to just drop this all in. These would be override. And this would inherit from TL state base. And then I'm going to go back into my agent, and I'm going to grab the enter red light state. And we're going to go back into the state itself. We can drop that in. And this would be agent. We wouldn't have... So in this case, all that we would need would be We wouldn't be setting the red light state. Let me comment this out. Hold on. So we would, in this case, we would have, it would be a public, oh boy, public, TL, state base, current state class. And literally would be agent, current state class is equal to this. And then we'll see a lot of dot agent in here. Oh, we don't want to play with this. Sorry, we won't have to set the enum anymore. And so now, again, we would be able to. Ideally, what we would then back in the traffic light agent, we would again, for our purposes, you know, public void change state TL state base next state. And again, we would then current state class. Exit state. And then we pass this as, and we pass, you know, this class as the agent. Then we can then basically next state dot enter state. And we can actually do this. And it's whether we do this here or do that there. It's, you know, that's one of those. Depends on how you feel. But what this then ends up happening is that rather than current state function. Rather than the evoke, this is a delegate method. And then finally, we would then have current state class perform state. And we pass this along. In fact, rather than enter green state in this case, we would end up having what do I call it? Sorry, change state. We would then have TL red state. There we go. Okay, there is one thing that we have to take into account. And it's down here. If current state class is equal to null. Sorry, it is not equal to null. So this is to make sure that we're not on our first change state call. We're going to go to red right away.
Wouldn't it be easier if you just like moved all those methods into the TL state base?
Well, it's well in the sake of the class, they are going to all of these functions are going to get pulled out of here, and they're going to get pulled into individual state classes individually.
Mm-hmm. But like the set material and all the other dot agent stuff.
I got to refer to where's all the data. It's in the agent.
Yeah. Okay.
Yeah. So the reason I'm giving them the agent is so that because all of this data
Mm-hmm.
is here in the agent.
Already, right?
Yeah, like the state time probably these variables are probably going to get kicked out of here and moved into things that would get again we wouldn't have enum anymore. Time counter probably is going to get moved into each state, if not the state base itself.
Mm-hmm. Couldn't you just move all of that into the state base? And then...
Not all of it. The objects, the materials, and the case. These are the big ones that can't move. Because those each class would have to know them. So the agent knows them.
Oh, okay.
Yeah, this is basically, let me actually move these down here. Yeah, I mean, this is the information to the traffic light itself. I mean, like the object for the red light, object yellow, the material on, off, red, yellow, and green, the case handles. The individual state classes don't need to have these because if each basically what would end up happening is that each of those classes would have to need these assigned.
Yeah, get a reference.
Yeah, this is. These are our agent is running a class that's doing work for it. Mm-hmm. So that's where we're passing the agent to them. Like, hey, this is to make our lives easier.
I like the delegate method.
It's kind rather than doing a delegate method, we have a class that's doing the work for us.
Mm-hmm.
And what this means is we can have multiple agents running. It's just a matter of setting the classes. Same thing with the function method. So there's two different ways of we are doing things.
Probably have to rewatch all that. Because when you said multiple agents, it's more like
Multiple instances of let's say we've got 3 traffic lights, and they are all behaving different. They have different behaviors essentially.
okay.
We can go in, and and that's one of those questions like the traffic. One of the things that could be part of it is that like these are also part of the class, like the agent, the traffic light agent itself.
Mm-hmm.
So we can set these at the agent level, and the class is going to look at that. It's like each of those state classes are going to look. Oh, okay, this is the time that the agent wants me to use. But I know there's like I've shown you 3 different ways to how to do this. Each of them have their pros and cons. Like don't get me wrong, the state enum has the least amount of work up front, but the infrastructure is in this enum states. The delegates, basically, for our purposes in the update, basically is like, hey, we're calling a function that turns it on and sets the delegate. And then this here, we're going to invoke the delegate. Again, here, we're just setting classes. I know we had a hand up over here.
Yeah, I was just curious, it was me. Those are both the same ways, but in terms of.
They are.
The second way you did it, that's for more complicated things, is that right?
Yeah, the delegate.
That's the right way to do it.
Yeah. So this is
Realistically, we wouldn't need it for the traffic light. For smaller objects, I guess.
class. So you can get away with the traffic light using the enum, but I'll tell you, this is ugly code.
Yeah, the second way is the right way to do it, right?
This is more. It's not. I don't want to say it's the right way. It's a more cleaner way of doing it. Because we're setting not. So we're not worrying about an enum that's handling things. We are instead setting a delegate instead to perform the basically, because we're only doing the on do. That's because that's basically what we're doing here. Don't get me wrong. There are times and places for each of the states. There's a time and place for having an enum. Like Unreal has places where they're using enums. Enums are great for being upfront with that. Where enums are great when you're upfront, like they're easier for other programmers to use because it's a value you're basically passing. Set state. What is the next state? Give me an enum. Again, in those who are in the C++ class, one of the questions you had was about an enum that is related to when we fire off this event with this action. You had an enum that said under what condition are we dealing with? Was it started? Was it triggered? Did it end? And there were two others I'm blanking on it as well. Canceled, and then. But we also, in those of you who are in the mobile development course, you saw the touch phase event. Start, end, canceled, stationary, and a moved event. So we had 5 different states, 5 different conditions of that touch. There was 5 different phases that we accounted for. So I'm showing it's not that the enums are bad. It's not necessarily they're bad. They are the most restrictive. If you are like with the touch phases, there's only going to be 5 conditions which you're dealing with that touch screen. So the enum makes sense. It's easy to use up front. Underneath the hood, it's ugly. I mean, the other way that you could have done this was like multiple if light state is equal to traffic. Let's grab this. And, it could have done it multiple list statements. In fact, I would prefer I probably might have written this multiple list statements rather than a switch. Because that's how I roll. I don't like, again, I'll be honest. The switch case structure is ugly as heck to me. You can use you can use blocks of code. It's just not usually done that way, and it looks weird. Yeah, this reads much cleaner. So again, the big thing about enums is that the reason is that the switch case structure is ugly. You're better off just writing multiple if statements quite honest. But the thing is that enum is not inherently extendable. If you had to extend another state to this class via the enum, we got to add something in the enum, and then anything anywhere where you've used that enum in a switch case or sequential if statements, you've got to add a case or an if statement to account for that state. You've got to deal with two different things to handle it properly. Whereas you're not worrying about that with the delegate. You're not worrying about that with the objects. Sorry, you're not dealing it with the delegate method or with state classes. You're not dealing with that. You just write another delegate. You just make a new delegate and you can assign it to it. Make a new class and have it yet be assigned as the next class you go to. And that's all you need to do. It's more fluid, it's more extendable. But you need to know all of you need to know all of these in action in order for this to come into play. All right. So moving on. All right. So that's, again, I've gone over a lot here. This lab is due in, I believe, 2 weeks. It's the longest. You've got a lot of time to work on this lab. I might extend this. This is literally due before. I'm going to look at this. This is literally due before you go off to spring break. All right. So those of you who are behind with the other labs, don't worry. This lab, you will get there when you can get there. So this is about setting up this object right here. Why am I talking about this? Let's go to the part 3 of your lab. Actually, let me go to. So map part 1 is working with the nav mesh. Let's go back to Unity. Let's go to our package manager. Go to the Unity registry. So about the package manager, go to Unity registry. You want AI navigation. And install that. All right. When we talk about AI, we're not talking about ChatGPT or the large learning model. No, this is a different type of AI.
It's NPC behavior.
This is NPC behavior. This is not generative AI. So when we talk about AI, so literally the AI that we've been talking about in your syllabus, that's talking about ChatGPT, these generative AIs. This is a different AI. It is what's in your syllabus does not apply to this. Straight up, does not apply. All right, that's how different of an AI we're talking about. All right. Again, this package installed, you can build and use NavMesh's runtime and edit time, create dynamic obstacles, blah, 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 blah. Cool. So let's jump in. Let me save this map. There we go. Control save. Let's go to. I'm just going to literally just grab these scripts and drop them into part 2. Yes, everything has changed. Close all tabs. There we go. Part 1, and then we're going to do one more folder. Part 3. Okay. So map 01 and 02 are going to be very much the same. It's just, we'll look at, so map 1, bring this down. So for our purposes, we have the ground, we have our player, and we have a sphere. All right. So our purpose is basically, and then, I'm actually going to duplicate this. So this will be the select sphere. And I'm going to turn off the collider on this because we won't need it. And this is going to be the target sphere. Okay. The target sphere, basically, I'm just going to go and go into materials. I'm going to make it red. So basically, blue is going to be our cursor. Red is going to be the essentially the basically our where we're going to target things. So we know where it's going to go off to. This is why this does not have a won't have a collider on it. It's just marking a point in space. Okay. We do need to add and when you add it, you'll have a new AI thing. There is surface, modifier volume, and nav mesh link. We're going to start with nav mesh surface. And set this at 0, 0, 0. Just to because our object is at 0, 0. Make sure this is at, make sure you put this at negative 0.5. That will make our lives easier. So here's the nav mesh surface. What we want to do is basically clear and bake it. I believe my ground, I have to tag that as static. And then I will clear it and I'll bake it. Agents. Path polygons. Here we go. Here we go. Show nav mesh. There we go. So for our purposes right now, we've got these two objects right here, which are considered, even though they don't have colliders, they're being considered as part of the mesh, which we don't want. So we're going to go back and we can just bake it again. And off it goes. And you can see the agent right here for our purposes is floating above the ground. And that's basically so it doesn't interfere with the mesh below. These are our, for our intents and purposes, are they are our dynamic pieces of our level. Camera. Let's just make sure directional light, ground, player. So I've already given you a navget mesh agent here. And that's going to be basically going to help us. I can put these back down on the ground. Target sphere, nav mesh surface. I'm going to move this up here. Yeah. Okay. I'm going to collect the nav. So I'm basically going to write a script here. So let's go to our assets lab. Oop. Part 1. Create a. I'm going to call this player agent. We'll assign this to the player. And let's go in. So we're using Unity engine.ai. And this is because basically our first thing is our nav mesh agent. We also want to know, we're going to do a lot of work in here, so we do want to know where the camera. This is actually going to be public. So there's a lot of work we're going to do with that camera. We're going to do cast into the world. We do want public, let's just do transform. Select sphere. Target. All right. I'm gone about an hour already. So I'm going to take a moment. I'm going to stop the recording. I need a few minutes. I need to get more to drink. And then we'll continue. So.
Yes, please. Hydration is necessary.